Yeah.
Hello, everyone. Hi,
Hello.
folks. Hey. Um, Hi, my name is Safia. I'm a software engineer on the ASP.NET Core team here at Microsoft. I help build things like minimal APIs, MVC, all of that fun stuff that I'm sure you all love to use or might be interested in using eventually for building web applications once you've learned C Sharp. I am joined today by a friend from the community, Samson. Do you want to introduce yourself?
Yeah, sure. So Samson Amugo, a software developer. I'm also a Microsoft Resident Ambassador. I'm Nigerian, and I think I could also call myself a C Sharp advocate.
Nice. So it looks like we have got a solid pair between the two of us to take you all through today's Learn module, which is all about taking your first steps with C Sharp. Now, Samson and I are actually going to walk you through two different modules with the help of our moderator, Laurent, who is on the call. He's going to be there to help answer your questions as well as bubble any questions that would be interesting for us to answer up live to us. So Laurent is also your steadfast friend over on the moderating crew. We'll be working with you to go through two Learn Live modules today. The first is writing your first piece of C# code. Samson is going to kick it off and help you work through that. And then I'm going to take it from there and guide you through the next module, which is all about storing and retrieving data using literals and variables in C#. So kind of learning more of those programming primitives or key programming language concepts, specifically as they relate to C#. Going through this module. You can find the AKMS links for the modules on this page. We'll also be referencing them quite frequently in the talk, so you will definitely not be lost. There's also QR codes up here for you to scan. A little bit of a more detailed breakdown for these modules. Samson's going to guide you through the first one, talking about writing your first pieces of C# code, using different techniques to print messages, and of course, the most important skill set, I think, for developers to have, which is the ability to diagnose errors that you might get if you've written incorrect syntax and the compiler is now complaining and quite angry at you. From there, we're going to pick it up and talk a little bit more about the data side of things. We'll talk about creating literal values for some of the basic data types that you might encounter in applications that you build. And then we'll talk about variables, why they're used, why they exist, and how to interact with them in the C# language. That is a pretty packed agenda. So I'm going to dive right in and hand it off to Samson for the first module, which is your introduction to C#.
All right. Yeah. So guys, I'm taking you through some. I think I'll call that baby steps. I'll call it baby steps in C# because it's literally about the fundamentals and basics of C#. Could you go to the next slide, please? Yeah, so we're talking about C#. In case you don't know about C#, C# is kind of popular and it's used in a lot of different industries, ranging from the mobile development industry, the desktop industry. You could use it to create desktop apps. You could use it in the gaming industry too. Maybe you're familiar with a gaming engine called Unity. The language that's used a lot in writing the gaming scripts is C#. Then you could also use it for currently the C# is building a huge community that's coming up in the machine learning world as well. So you could use C# also for machine learning. You could also use it for business application like banking applications, server applications. You could use it for a whole lot. So I think that's why you could actually call C# a general purpose language because you could use it literally anywhere. Yeah, the next slide.
Yeah, that's a good point to call out. And when you're building web applications, you're probably going to be using ASP.NET, which is my favorite technology, obviously, because I work on it.
Okay. So we're talking about how to write Hello World in C#. And I think you've heard a lot about Hello World, but I think you don't know about the history of Hello World. So I'll just add up that trivia there. So the culture of writing Hello World as your first action or first learning experience when picking up a new language could be traced back to 1972 by Brian Kennedy when he tried to demonstrate memory management in strings in a programming language called B. So we have B, we have C sharp, and a whole lot. So that is how. So after that, it kind of became somehow iconic for people to try out printing out Hello World to the console. Mm. So I'll be. Can you like enter the next slide? All right. Um. So when you're trying to try out instructions or give your computer commands, the you could use your terminal to write it, but for beginners that is not really advisable. It's advisable that you use a friendly editor. So I'll be sharing my screen now on that. So, but before you start using C sharp on your system, you could browse about downloading the .NET SDK. So the .NET SDK allows you to, it gives you a set of tools that allows you to write your C sharp application on your computer and also compile it as well. Then you could, there are websites that allows you to, write your C sharp code. And if you're already familiar with web development, JavaScript, HTML, and all not, you could as well write your C sharp in VS Code. And as you can see, I just have like a basic layout of a console application. Then if you're familiar with Jupyter Notebook, you could as well write your C sharp in Jupyter Notebook. All you have to do is to have your .NET SDK installed on your system. Then you should also have the .NET Interactive Notebook extension installed. And with that, you could, try out some C sharp code on your system.
Cool. I think it's
Yeah.
cool that you're showing us there's all these different form factors for interacting with the compiler. You could use Jupyter Notebooks, you could use try.net, you can use even the editor in the module, but they all use the same C sharp compiler. So the same principles apply throughout all of these different form factors. Yeah.
Exactly. All right. So I would be carrying out a sample example here on Hello World. And I think I'll use my Jupyter Notebook for that. So, let me use the browser. All right. So I'll be trying out the C sharp code in a browser editor called sharplab.io. So sharplab.io allows you to execute and run some C sharp code right in your browser. And let me clear this. So there's something called namespace in C sharp, and namespace like contains many different types of classes. So when you're trying to like print out to the console, there's a class under the system namespace called the console class. So the console class contains like different methods that allows you to carry out or execute different actions in your system. Sorry, on the console. So I'll start out by typing the console class, then I'll put the dots. Then as you can see, all these options here, this is what is called IntelliSense. So it's giving me a list of possible options or actions I can execute. So I'll be trying out the right line action or method, and I'll say Samson because I want to print out Samson to the console. Then in C sharp, after every command, you should end it with a semicolon. So a semicolon is used to end the statement. Sorry, it shouldn't be here. Yeah. All right, cool. So now in between, you could see after my right line method, you could see that I have a parenthesis, and inside my parenthesis, I have the word Samson enclosed in a double quotation mark. Now, usually in C sharp, the compiler does what is called precompilation. So in the pre-compilation process, what happens is that as you type, the compiler, executes your code in the background and checks if you're actually adhering to the standard, if you're conforming to the standard. If you're not conforming to the standard, the compiler starts screaming, hey, 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 change this, that kind of stuff. So yeah, could you switch back to the slide? Hmm? Yeah, I think I've explained. Could you go to the next one? All right. So what is a programming language? A programming language is basically a language that's used to instruct the computer and tell the computer what to do. It could also be said to be a set of vocabulary and grammatical rules that you could use to instruct the compiler on how to, process your commands and give it to the computer to execute. Now, next slide. So now when you're dealing with a programming language, there's something called a compiler. So a compiler serves as an intermediary between the programming language that you're writing in and the machine. So what happens is that the programming language is something that is human readable. You could actually, write in that language. And the compiler converts it into machine code, zeros and ones. And the machine actually executes the code by flipping some switches. You could call those switches transistors in the engineering world. Then next slide, please. Okay. So now when you're writing in a programming language, you have to make use of the syntax in the programming language. And syntax are just a bunch of keywords that you could use in the programming language to, write out your commands. And also syntax also conforms to a grammatical rules that the compiler enforces. So, okay, then one other thing you should note is this for this syntax is that there's something called syntax highlighting. So syntax highlighting is, could you, I want to share my screen, please. Yeah. So for syntax highlighting, like you can see here, this using has a purple color. So this is used to separate this command from this. So you could say syntax highlighting helps to segregate or group your commands, your syntax into, and actually give them meaning and group them. Also, syntax highlighting could be used to show or tell you when there's an error like this. You could see I'm not actually using the correct.net, the correct C# standard to write this. So you can see this squiggle sign here. So this squiggle sign is like telling me, hey, you're actually making a mistake. Could you step back and figure out what you're writing wrongly?
Yeah. So a key part of the language is the fact that there are these rules that exist. The rules support doing things like syntax highlighting in the editor, and they also support providing you with errors if you haven't followed some of the rules of that language when you're running your code. Got it.
Exactly. Yeah. So the next thing I have to do is that since this is shouting, the compiler is screaming, telling me, hey, Samson, you're writing this wrongly. Try to adjust this correctly. So I'll have to, put it back correctly. So everything seems okay, and it's giving me my result as well. Also note, in case you're using SharpLab, to ensure that this drop down is set to run. Yeah. So I think we can continue from the slide, please. Oh, I think I made a mistake there. All right. So let's try this out. I'm to write this instruction and capitalize. Okay, nice. All right, so I can go back to my editor, please. Yeah. So one thing you should note is in C# is you can't just use lowercase letters in case of uppercase letters. So what I mean by that is, like this, we have the console class here. I can't say C. I can't use a lower letter C for this. It has to be an upper letter C. So yeah. So you could say that C sharp is case sensitive. Then one other thing is when you're writing your commands, you must ensure that you enclose them, you terminate them, you terminate them with a semicolon. You don't terminate them with a semicolon, the compiler will also scream at you. Then for things like methods, if you want to call a method in C sharp, you have to ensure that you use the parenthesis. So the parenthesis is called an invocation operator. Then this dot here is called an a member access operator. That is what it's called. We have other operators in C sharp that allow you to perform different actions, like the addition operator, the subtraction operator. We'll just stop
So
here
each
for now.
piece of syntax is kind of associated with the operation it correlates with, and they refer to things like accessing a member or calling a method or adding two values to each other.
Yeah, sure, definitely. So I think we could go back to the slide now. All right. So understanding the flow of execution in C sharp. So when you're writing out your codes in C sharp, you would have to understand that the compiler executes your code one after the other. There might be some times whereby the compiler would have to terminate a particular portion of execution in a particular method or function and continue elsewhere due to the way you decided to write out your code. But we will not be discussing about those complex areas now. We'll just talk about a sequential execution of code. And I'll want to write out that I want to write that in my editor. So we can go back to my editor now. So right here we have console.writeLine in my editor. And if I write console.writeLine Sapphire, yeah, one thing you notice is okay, let me do this. So if I have another command here, the console.writeLine command here, you see that it doesn't print out to the console, doesn't print out to this text editor starting from Sapphire. It starts from something. So you can see that the code execution is actually sequential, is not random. So as you're coding, you also have to bear this in mind that what I'm writing is going to be in a step-by-step procedure. Like I said earlier, there are also sometimes where you would not want your code to execute step by step. Like literally, maybe you might pause at some particular point and continue elsewhere, maybe not on a different thread. But we're not talking about that. We're not talking about that now.
Yeah, I think that's an interesting point to bring up, though, because even though we might write code, and if you've written code in other programming languages, we might write code that uses if statements to make decisions about what parts of the code should be executed or loops. It's all happening sequentially down at a very low level on the CPU. So kind of two interesting worlds to keep together in your mind.
Yeah, that's true. Okay, I think we could get back to the slide. So yeah, we have some challenges to do, and let's see what the challenge is. So code challenges throughout the okay. So to print out these two lines using the two different techniques. And currently what I've actually taught you guys is just how to print out to the console using write line command. So immediately, soon enough, I'll just also introduce the concept of using the right action or the right method to bring to the console. So let me do that now. So back to my screen. So here we have been using the console write line method to bring to the text editor or the console. And one thing you should note using this write line method is that after writing something, it enters the next line. So you could say that the write line method terminates its execution with adding a new line to the text editor to the console. But if I were to use something like the write method, so if I'm to use something like the write method, you'll see that it doesn't add the new line or the return carriage after Sapphire. It just immediately it just immediately appends Microsoft.
So different methods have different behaviors. Write indicates that it doesn't end with that line termination or that new line terminator, but write line does. So you can kind of mix and match to print your desired output. Nice.
Yeah, exactly. So let's try out
Samson,
something.
can I give you a pop quiz?
Yeah, sure.
How would we print a new line using only the write command or the write method?
Okay, cool. So in a situation whereby you want to use the write command, the write method, you would have to manually add the new line string or character. So you can do that by, let me see. Let's say by doing this, I think.
Yeah, that looks familiar.
Then if I write something like, if I attach a new statement to the console, you'd see that it actually enters on a different line. So let me say Sapphire here. Yeah, so you could see, so what the write line command is doing underneath of, at the background, is that it's adding this character, this new line character, to the word you're trying to print to the console.
Yeah.
So if I'm to use the write line here, I don't need to use this again, because it does that for me automatically.
Cool. That makes sense to me. I'm starting to build a mental model of how all this stuff works.
Okay. All right. So let's say we have this string or this statement. This is a house, and I have another one called this tutorial is about C#.
So Samson, what are those 2 forward slashes you've included in your code?
Okay.
I have not seen those before.
All right. So nice. So when you're writing your code and maybe you don't want the compiler to execute a particular line, you could use what is called comments. So for you to actually write comments in C#, you have to use the backward slash. Yeah, you have to use the 2 backward slash to identify that you're trying to write a statement or a sentence that the compiler should not look at. So once the compiler is trying to execute your code, the compiler would overlook that comment or those comments. So when you're writing comments, you could actually write comments in a single line, or you could write comments in multi-lines. For you to write comments in multi-lines, you use the backward slash with an asterisk sign, and you can write, let's see, okay. This is really good to know and fresh.
Nice.
Then I'll close it with an asterisk and a backward slash as well. So you can see the difference between the single line comments like this. These ones are the single line comments, and this is a multi-line comments. So this is how you write comments in C Sharp.
So every line of code has meaning to a compiler. If we want a compiler to ignore certain lines of code, we have to explicitly comment it out using this syntax.
Yeah, sure. Definitely. Okay, so back to what I was trying to write. I was trying to print out these two statements using a combination of both the write line and the write method. So let me start out with writing the first one, console.writeLine. So remember that console.writeLine method is used to print out the console and also adds an extra line for you, a new line for you. So I write here, this is a house. Then I'll close it. Ensure that I close your statements with a semicolon. Then for this statement here, I want to write it using the console.write command. So I'll say console.write. I'll take this tutorial. This tutorial is. Then I want to add this extra space, this single space. I want to add it. So I have to include it here. I'll give the space and close it. Then I'll terminate this statement as well with a semicolon and continue from the next line. Console.write. I'll start off with my quotation mark and say about C Sharp. In case you're wondering how I'm able to like open this emoji palette in Windows, you could do that by holding the Windows button on your keyboard together with the dots button on your keyboard. So
got it. Now I think this is cool because you've got this sequence of characters here, and it's just letters and punctuation so far. But you can also include emojis; those classify as characters too, or something that can be printed.
Yeah, sure. Oh, so I have an error. I don't know if you can guess what the error is.
Well, this is one of those errors where the actual messages that you get warning you about the issue are not very clear. I spotted that you forgot to include the closing quotation in your string. And so that's just completely frustrated the compiler. It doesn't know how to parse it now. It can't figure out that you it's basically looking for you to complete the invocation operator with the closing parentheses and the statement with the colon, but you haven't even finished wrapping the string. So it's just totally lost.
Exactly. So now I can close it and it executes. So we have these two sentences, your statements being printed to the console using a combination of both the write line and the write command. Now, one of the errors that I would like to let you know is this. What happens when you use a single quotation mark to wrap around your word or your statement?
Ooh, I think I know what's coming, Samson. It's not pretty.
Yeah.
Yeah.
So what you see being printed out is this error saying too many statements in character. Okay, too many characters in character literal. So basically, what it means is that, okay, I didn't actually talk about that. For what a character literal means is when you print out just a single character. So a literal is basically something that is fixed and cannot be changed. And here we have a character literal. You also have other literals which Safia will talk about in our own slides and explanation. So this is a character literal, And there's a difference between a character literal and a string. So that is why you'd have to use double quotation marks to represent your string. So
I
now
see.
it's brings to the console. Yeah.
So different types of literals need to be communicated to the compiler in different ways. Single quotes for character literals, and then double quotes for string literals.
Exactly. All right. We could head back to the slide. Let me see what we have next.
I think we have some knowledge checks coming up.
Cool. All right. Let's see. Let's see what we have.
Yeah. So you can check out the link. It should be posted in the chat or the QR code if you want to follow along with these poll questions we have. Here's the first one, Samson. I'm wondering if you could help me figure it out. What is the primary job of the compiler?
The compiler primarily locates spelling mistakes in your code. I mean, it does that, but it's not really the primary.
But it's not the primary reason, right?
Yeah.
And actually, I don't even think it does that. I mean, it doesn't detect spelling mistakes. It detects if you have, referenced a type that doesn't actually exist, for example, and the reason might be because of a spelling mistake, but it doesn't, it's not like you're spelling a grammar checker.
Keyword spelling mistake, you could say.
Yeah.
What about the next one? Compiler primarily reformats your code. That is not also the primary.
That is definitely not it, because it complains when your code is poorly formatted for any reason, like missing a semicolon. And also, in some ways, the compiler might not care about the format of your code if you have extra white space or if you've ordered things a certain way. There's some types of formatting that your compiler doesn't really care about. If you put your curly braces on a new line or the same line, it's all the same to the compiler.
Then the next one is C. The compiler primarily executes your code. Okay, let's see D before we could, conclude on that. The compiler primarily converts your code into an executable format that the computer can understand.
That looks like the best option. What do you think?
Yeah, definitely.
Oh, looks like we were right. Yeah, and there's a subtlety here. Compilers produce code that can be executed, but compilers don't actually execute the code. They're kind of part of this long magical process that changes the code you write to stuff that actually runs on your computer. That's cool. I think we're doing pretty good so far about this next one here.
Yeah.
Which of the following statements is true about C#? C# is case insensitive. Emphasis on the insensitive. I'm not thinking this is correct, because C# is case sensitive if you have
we tried that out
earlier
when I changed the C in console to a lowercase c, and the compiler was screaming.
Yep. So we can rule out A. How about B?
Console is a method and WriteLine is a class. Nope. That's going to be it. So
I think it's the other way around. Console is a class and WriteLine is a method, right?
Yeah, sure.
Okay. C is looking like maybe the best option. I've taken a sneak peek at D.
D? Yeah, it's
yeah.
All of C. So C.
Yep. All right, so far so good. I think this is our last question. Let's see if we can bring it home.
Okay.
What is wrong with this line of code?
So A says the L in WriteLine should be lowercase. And we looked at how or what the WriteLine command should be, and that can be it. It's always the W should be in uppercase and the L should also be in uppercase. So that can be it. Then B is missing a semicolon at the end.
Yeah, it is.
Let's say that. Okay, let's see other options too. The string should use single quotes. No, we talked about that last before this.
Yep.
So when you use single quotes on string, the compiler screams at you. And this says a comma should be used instead of a dot between console and write line. And that can be it because, to access the members of a class, you have to use the member access operator. And member access operator is the dot. So
Yeah.
the
Punctuation has
answer
meaning
is,
in programming languages, and commas definitely do
yeah.
not mean member access. Yeah.
So the answer is B.
I'll look
Yeah.
at that. I think we're 3 for 3.
Mhm.
All right. Do you want to wrap up this first module, Samson, with everything that we learned today?
Yeah, sure. Right. So, going through what we learned, I'm sure you've learned about how to print to the console using, or how to print to your text editor console using the two different techniques we mentioned, which is consider write line command and the consider write command. And also, when you're writing out faulty codes in your text editor, the compiler does what is called precompilation. And if it sees any problem in your code syntax, it screams at you by, using that squiggle sign that I talked about. Then you also got to learn about some C# specific syntax and keywords like classes and when to use your semicolon to close your statement. You also learned about different some operators. There are a whole lot, but you learned about some operators as well. And you learned about classes, methods. So that'll be a wrap for this session. And next will be over to you, Safia.
Yeah. So I have terrible news for everybody, which is that programming is not as simple as printing strings out all day. If it was, we would all be having a much funner time. But unfortunately, it's a little bit more complex than that, specifically because we interact with all sorts of data in our applications. Whether you're building a web application or a console application, you're working with data that's stored on a computer or created somewhere, maybe saved. Data drives programming or programs that we write. And so programming languages should have really nice primitives and syntax for interacting with data. And we're going to talk a little bit about that in the second module. And we'll dive right into it with something that Samson talked about, which is the notion of literal values. I'm going to jump over to the literal values exercise in the Learn module, and we'll just kind of skim through it. Samson did a great job of working us through the basics of the material covered here. But just as a quick reference, literal values, as the name might suggest, are literal, literally cannot change throughout the execution of a program. So if I say console write line, the character literal B, like I have here, it's going to print out B, and nothing can change it during the execution of the program. The only way I can change what gets printed out is if I go back, change my B to an A or whatever character I want, and then run my program all over again. So literals are these data types that are instances that can not be changed. Variety of literals exist. We talked about character literals, which, I could print out a single character like A. I can also print out, here's a trippy one. I could print out the character literal 1. This is not representing the number 1. It's representing the character 1. Why is this interesting to point out? Well, depending on the type of the literal, different operations can be applied on it. So for example, the number 1 as an integer, which is another literal type or third literal type, you can add numbers, you can subtract numbers, multiply them, divide them, use them as inputs to methods that take numbers. But you can't really mathematically add characters, right? Like there's no math that explains how you add the letter A to the letter B. So the data types of a literal or any type of value represent what kind of operations you can do on it. So characters, I might be able to add, or I might be able to change a character. I might be able to split on a character. With strings, I might be able to concatenate two strings together. So one way I could do this, if I say hello space plus world, that is going to print out hello world for me, but I've kind of done it in this unique way where I've used the add operator, not to add numbers, but to add two strings together, where the add here is actually overloaded to mean concatenate or combine these two strings one after the other.
I have a question there, please.
Yeah.
So my question is, what happens when you try to concatenate character literals?
Oh, interesting. Well, let's not try it and see. So let's see. You're saying if we had a character literal, and let's say we did it, concatenated it with another character literal.
Exactly.
My bet is that we're going to get similar behavior to a string, or maybe not. It looks like what this has done is printed 46, which I think is the ASCII character code for the letter A. And I bet if we change this to an A, we get the
Nice.
Oh, you know what? I think we're running into buggy behavior here where it's trying to use the add operator on a character.
Yeah.
So the behavior differs for all of the different types with respect to how they're mapped and then what operations can be processed on them. That's a great thing to call out, Samson. Not all the rules make sense for all the different types. Adding makes sense for numbers where I could do 3 plus 2 and I expect to get a 5. Cool. That was kind of an exploration of 3 of the literal types. We've talked about strings, integers. Decimals are another literal type that we might want to represent in our applications. Literals are a little bit, or decimals are a little bit different than integers because they have that fractional component. So we could see here, if I want to represent a 12.3 as a decimal value, I kind of indicate that with this suffix on the actual literal with M to denote that here. We're basically giving the compiler a clue or a hint that we explicitly want the 12.3 to be treated as a decimal type as opposed to an integer or whatever other parsing it might do. So we can also use syntax in our application to give the compiler clues about how things should work. Oh, another type of literal is Boolean. So maybe I want to represent states that are binary in nature, either true or false. We can do that with a Boolean literal. So here I have true, false. Typically, you're not going to be printing these out. You might be using them in the execution of your program, maybe as part of an if statement or some kind of condition check. But again, that's another kind of core literal value. And really the important thing to emphasize, we saw this while we were playing around with different integers and characters, is that different data types have different behaviors that you can execute on them based on, the data type of that particular literal. And the one thing you'll notice here is that I'm using literals all the way through. So I'm not able to change any of the values of these properties or data's instances at runtime. If I want to change what gets printed out here, I have to go in literally into my code, change it from true to false, run it again, and then I get the change in behavior. There's no way for me to change it at runtime, which is where the concept of variables comes in. We talked about literals being hard-coded values, literally hard-coded values. Variables can change their values, and in particular, they can change their value throughout the runtime or the execution process of a program. So to declare a variable, you need to inform the compiler of 2 things. First is the name of the variable. This is a unique identifier that you're going to use to reference the variable all throughout your program. You can think of it as a label on a piece of data. And then the second, we talked about the importance of data types of different things in our program. So the data type is actually another aspect that you will need to provide when declaring a variable. Segue on naming. Naming is hard, especially when we want to use names to communicate meaning in our applications. You don't want names that don't make a ton of sense. Like maybe I am defining a variable that I'm going to set to an integer that is going to indicate the amount of money that is in a person's bank account. Obviously, a terrible name for that variable would be something like number of chickens, because that is not what that data or what that instance is communicating in our code. So we have to be sensible about how we name our variables. And most importantly, variable names are one of the things that emphasize the value of programming languages, which is that they provide this human readable surface area between what a machine actually is doing behind the scenes, which is like ones and zeros, electricity flowing through different transistors, as you were saying earlier, Samson, and what we as humans interact with, which is syntax that has meaning that we can read and kind of understand what a program is doing or what the flow is.
Okay.
So yeah, naming is hard. There are a ton of different rules for naming variables. And then there's also some conventions. So there's things that you should not do. For example, variables can't be a keyword. So you can't have a variable called string. You can't have a variable called decimal or int or any of that, because those are reserved keywords that the compiler understands and has special meaning for when it is parsing a piece of code. You can have variable names that, are not keywords. So I could use something like string to represent person name or something like that. Obviously, that wasn't a great example. They can be alphanumeric, so you can have, characters and numbers in them. And there's kind of conventions that exist. So one of the conventions or best practices that exist is that variable names in C# are generally using camel case, which means that the first letter is lowercase, and then the first letter of each subsequent word is uppercase. That's just a convention. You could use a different style for your variable names, but collectively, people who write C# code have decided to use camel case. So there's rules and conventions for naming variable names. Rules are the things you absolutely must follow. Conventions are best practices that you want to follow because it makes your code easier to read by other human beings.
Cool.
Yeah, here's a ton of different, not a ton, I guess it's only 4, but here's some different examples of variable names that you'll want to use in your application. I can have variables for chars, ints, decimals, booleans, and each of them communicate a different concept. I have a game score, user option, particles per million. You'll notice that all of the variable names that are listed here have meaning that is specific to the program they're running in. So game score, that gives me a hint that I'm probably reading some code for a game or a video game. Particles per million, that gives me a hint that maybe I'm reading some chemistry related program. So immediately, just like reading through these, I already have a sense of the meaning that's associated with those variables. So they're all really great variable names.
Sorry, could you go back to the previous slide? I have a question.
Yeah.
So when you're talking about the described types in C#, no, not this one, the next one. Yeah, so you have these laid out types here, the char, the int, the decimal, and the bool. So like, how do you know the particular one that would suit what you're like a use case? You have int and decimal, the same a little bit kind of related. So how do you know how to, differ between them?
Yeah, that's a great question. Obviously, int and decimal are related, char, bool, string. What your question kind of, Samson, was what data type is best to use for a given application. Kind of, I think the things that at least I think about when I'm reasoning through what data type to pick for a program is what operations do I want to be able to execute on this data type? Like, do I want to concatenate strings or do I want to add numbers? Like, what are the features or functionality that I want access to when I'm writing a particular program? It doesn't necessarily apply for some of these primitive data types here, but for some of the more advanced data types, another consideration I might have is the performance ramifications. So maybe there is a data type for representing a sequence of items that is a little bit more efficient or performant compared to another data type. So I might consider performance as a factor for what data type to consider. So yeah, functionality, performance, and I guess what API I want exposed. Like, do I want a data type that has APIs for all of these features that I might not necessarily want, or do I want something kind of more scoped and simple? Those are kind of some of the things that I think about when picking data types, and it's really specific to your particular application. Beyond, some basic principles for, use a bool in certain scenarios, or maybe use an enum in other scenarios. I think reasoning about performance, the particular feature set you need for your own application or where you're consuming that data type are probably the two factors for what data type I end up using in an app.
Right, cool.
Cool.
Nice.
Yeah, so we covered a little bit of the basics here with variables. They're essentially pointers to locations in computer memory. They allow you to be able to modify data throughout the execution of a program as opposed to having those literal values that are static and don't change. Variables need to be declared, and typically the declaration process requires that you provide a type and a name for the variable. Now, I said typically because there's some fun that we're going to go into later when we talk about implicitly typed variables. But first, we're going to practice what we learned here. I'm going to hop over to Unit 3, which is setting and getting values from variables. We're going to kind of play around with some of what we just learned. Cool. So here I have a piece of code, and it looks like this piece of code is doing two things. It is going to create or declare a variable called first name. And then it's going to assign that variable to Bob. Now, one of the things you'll notice is I've gotten a little squiggly, a little gentle warning from the compiler here that I've declared a variable, but I haven't used it. So I can kind of appease the compiler and dissuade it from providing me with that warning by actually using the variable somewhere in my application. Now, it's not just assigning to it, it's actually using it like I've done here, where I've printed it out and now it gets displayed as my output. Now, one of the things you'll notice here is that we have defined a variable as a string. And then when we assign it, we use the variable name and then this equal sign and then the string Bob. The compiler is very particular about the syntax here, about what you are allowed to have on the left-hand side of the equal sign and on the right-hand side of the equal sign. So something that is not acceptable to have on the left-hand side is a string. Pretty much the only thing you can have on the left-hand side is some sort of variable name or variable declaration if you're doing it all in line. So doing something like this, is a no-go. We have confused the compiler. It does not know how to process a string literal being on the left-hand side. It's not an acceptable left-hand property to use here. And you'll notice it's tripping it up in all sorts of ways, particularly if we hover here, it says the left-hand side's got to be a variable, a property, or an indexer. And those are all three valid types of syntax that we can include here.
One more thing, please. Like, could you illustrate using a type as the name of a variable?
Yeah, so I think what you might be referring to, Samson, is if I did something like string.
Yeah.
Yeah, exactly. This is a no-go. So this is breaking one of the rules that we talked about. It's great to point out, which is that we can't have a keyword or something that is a reserved word used by the compiler, like string, as a variable name. Otherwise, again, it gets super upset at us. Here it's saying, I expected an identifier, so something like last name or first name, but what you've actually given me is a keyword or reserved term that I understand here. That's a no-go.
Cool.
So, yeah, here's another sample of acceptable left-hand, right-hand combinations. I can assign a variable using the value of another variable. So here I could say that my last name is equivalent to my first name in this little program that we have here. Here we've defined the data type for our name or first name, which is a string. What if I decided to be a little bit chaotic and assign it to a number? So say that your first name is 3. I've confused the compiler once again. I'm getting this error. It says, I can't implicitly convert a type int to string, which is a long-winded way of saying, you told me that this type was going to be a string, but now that you've assigned it, you're actually providing an assignment to an integer, and this is not acceptable. So there's a couple of different ways I could fix this. One of them is I could just provide, a valid type here. I could provide a string like Bob. Another way is I can go and change the data type that is associated with my variable from string to int, and then I'll get the correct behavior here. If I set it equal to 2, and if I set it to Bob, it'll get a little upset at me again, because again, I've declared it as an integer, but when I've assigned it, I've set it as a string, which is not permitted here.
Screaming.
Now, one thing I could do is I might have a more general type here. So let's say that I had, a class called a person, and then I had, not sure if you could do classes in here, and then I had another class that was child that was inherited from person. I could do something like this, where I define a person type called human, and then I can assign that to a new child.
Okay.
And we're not going to run into issues here, because in this case, child is an instance or can be assigned to a human or person.
The first name, we should use human there, I guess.
Yes. Yeah, we want to fix this to human instead of first name. Good catch.
Cool.
Yep. Nice. So we've played around with a couple of things. We've actually already interacted or experienced with retrieving a value that's stored. Yeah, I think it's screaming actually, because the editor doesn't support top level programs, or I think it's upset that I've defined a class after. Yeah, so we've talked a little bit about how you retrieve values. You could just reference them directly in your method invocations when you call something like writeLine. You can also reassign values. We looked at that a little bit when we changed the value of last name to first name, but we could show a more intense scenario here, where I'm actually repeatedly changing the name or the value of the first name variable throughout the execution of the program. And printing out different first names. The last thing that this is going to hint us at is the notion of initializing a variable. So if I stick to just having the declaration for the variable first name and then the use of the variable, I'm going to get a warning that I'm using a variable that is not assigned anywhere in the execution of my program. And the compiler can do some clever things to figure out exactly when you assigned a variable. So you can have code that is hundreds of lines long, or maybe it's distributed against several different files. And the compiler will kind of resolve if a particular variable has been assigned. And if it hasn't, you'll get this little warning, which we always reliably get. It says, hey, you should probably be initializing this by setting it before you use it, so we can appease the compiler by actually setting the property there. So yeah, we can declare variables. Generally, we want them to always be initialized. There are some fun new things in newer versions of C# where you can initialize variables to a default value that is kind of empty or empty by default. And then you can interact and access variables and modify them throughout the lifetime of your application.
One other question, like you've been using stuff like string, and is it possible for you to, like, just declare a variable and for the compiler to like automatically infer the type that you're trying to use?
Yeah, great question. That kind of segued into the next portion of this and something I was implying a little bit earlier, which is the notion of implicitly typed local variables. This is the notion that it's kind of annoying for you as a programmer to have to explicitly define what the data type of a variable you're declaring is. It's just like one extra bit of cognitive load on you. Yeah. Now, wouldn't it be great if the compiler could actually determine what the type is by analyzing the program and making a best guess about what the appropriate type to use is? It turns out there is, and it's called an implicitly typed variable. And the idea is that the compiler would kind of infer based on syntax and context clues what the type of variable is without you having to define it. And the way you tell the compiler, hey, I don't want to declare the type, I want you to infer it for me, is you use the var keyword. So where we would have previously used string or int or char, we're just going to say var, and the compiler is going to use that as a clue to say, hey, it looks like the developer wants me to infer the type here, instead of looking for an explicit definition. Okay. One thing is that in order to be able to make an inference, though, the compiler has to have some data to look at in order to be able to understand what the variable type is. So they do have to be initialized, and the initialization process is how the compiler gets the context clues it needs to determine the type of the variable.
Right.
Yeah, so we can actually see this in action if we hop over. It's over in Unit 2, talking a little bit more about these implicitly typed variables. We can use it to determine the type of a message, which here is a string. And then you'll notice the compiler has inferred that message is a string when we declared it using an implicitly typed variable. And then later on, when we try and say, hey, I actually want to set it to a decimal, the compiler is going to explode at us because we have invalidated the inference it's made about what that type is. Mm-hmm. So that's pretty neat. Cool. I think I've got a little bit of a challenge to work through too for this particular one. So let's see what that is. In this challenge, you'll write code that will combine literal and variable values into a single message. And it looks like I have got a string, int, and a decimal that I want to display. So let's see if we could take a stab and do that in this challenge. Cool. So here's the message I want to display. It looks like I'll be using console.writeLine. So I'm actually going to skip through to the solution, and I'm actually going to propose an alternative to this that will be a little bit better, hopefully. Okay. So here, it looks like we're defining all of our variables. Now, this is kind of weird. It looks like it's actually using implicit or explicitly typed variables for everything. So we can actually, why don't we just go ahead and replace everything with var? Because we know that the compiler can infer that that's a string. Let's leave this one as int and decimal just to kind of show the variety in all of those. And then the compiler or the solution that's displayed is using a console.write statement. And we're kind of doing what we did in the first challenge, which is we'll make a call to console.write, and we have it split up across different messages. So here's the thing. We can actually use a little bit of a different format here, which is use a format string. Again, this is syntax that is available in C# and that essentially allows you to integrate variables into a string definition without having to do this kind of nasty breaking up of console.write invocations into a different line. So the way it works is I've got this $ syntax that I place before my quotation that kind of serves as a flag to the compiler that, hey, we're going to be playing around with format strings here. And then I've got a series of placeholders that I can include, and the placeholders are indicated by that curly brace value. And here I can stick in name, which is going to actually, instead of putting in the string literal name, because it's in curly braces, it's going to reference the name variable. I can go ahead and do the same thing for messages. And then I could do the same thing for Celsius, I think. And that variable was called temperature, I bet. All right. And now if I run this program, I should get the same output different times. Let me actually pop in a new line here so we can see that. Cool. So we get the exact same thing printed twice, and that's because in one instance, we are passing the parameters or the variables as parameters to our write method directly. And in another instance, we're integrating them as part of a format string. Two different ways of doing the same thing. One syntax is a little bit better.
The last one is definitely more legible than the previous one.
Yeah, but I think an important thing to note, behind the scenes, the compiler has parsed this code. It's compiled it down to an executable, and the computer, all of this means the same thing to the computer. It means, hey, print out character H, print out character E, L, L, O, comma, print out character B, so on and so forth. So what the syntax and the syntax that is written, or the code that's written that is facing us, goes through different layers by the compiler and eventually into an executable format that's executed. And the benefit that gives us is you can communicate the same thing in different ways. And sometimes the different ways we communicate it can be easier or harder depending on what type of syntax we're using.
Okay.
Cool.
Nice.
We did talk through the solution. We also talked about how we can make it a little bit better using implicitly typed variables, as well as using format strings, which are all kind of syntax or operations that are available to you in the C# language, as well as quite a few others format strings you might have seen in other programming languages if you've had the chance to play with them. Yeah, that is one solution, but as we talked about, format strings are totally other option.
Before we get into the knowledge check, I have a question to ask.
Yeah.
And the question I have is, in which kind of situation would it be better to use explicit typing compared to the implicit typing, like using var?
I think there's two ways that I solve this. It's one where an implicit type might be a better way of communicating meaning to the user. I particularly tend to use explicit types when I'm using the new shorthand new operation in C#, which is kind of syntax for invoking a constructor on a class without using the full class name. Generally, I will use var if it's not totally and completely paramount for someone to understand what a type is before interacting with it. So for example, generally it's not super important to know that something is a string if you can kind of piece together from context clues how it's passed into other methods and things like that.
Okay, cool.
So yeah, and then if it makes sense, if I'm trying to use a compiler feature where an explicitly typed variable is preferred, and then also if using an explicit type is not going to add a lot of value to the person reading the code, I'll just use an implicit type variable.
Like
most of the time it's implicitly typed variables.
Like most libraries too, like if you check most libraries, they usually use explicit typings there.
Yeah. Cool. Right. Let's test our knowledge. Oh boy, this is having us be a little bit of a compiler, which is Which of the following variable names should or must be avoided? So B is the one that stands out to me. That's looking like the most well-written, convention following, communicates good things variable name. So I think the answer is definitely not B if you're following along. C and D, C and D are one of those things where the compiler will understand it, but I don't know if a human will necessarily like these variable names. So I think C and D should be avoided, but you're not going to get any like error messages when you use them. I think data is with the $sign up front. That one is going to be an interesting one because it's not alphanumeric. We've got the symbol thrown up. So I think that one is the one that must be avoided.
Yeah.
Nice. Okay, that's good intuition. So definitely avoid A, and you should avoid C and D. And B is a good example of what to use. All right, next up, what is the problem with this line of code? var message. Okay, so one, var isn't a data type. Kind of. This is incomplete to me because really the problem is that you're using var in a context where you should have initialized the variable. Like B is the complete idea here. The var keyword is only meant to be used, or the var keyword should be used with a variable that's initialized so the compiler can infer the type. C and D are,
they can't actually be the answer.
Yeah. So I think it's B is the correct and complete. Nice. Cool. All right, let's see if we can keep this streak going. Which of the following lines of code creates a variable correctly? All right, so let's go through these one by one.
Yeah.
We've got
so
A.
No.
Yeah.
It has an M. And I think when we were talking earlier on, anytime the literal has an M, you could actually point that, you could ascribe that to a decimal type.
Yeah.
So we have B having an M and the type being labeled a string. So B shouldn't go. And you also have D. The first there is a string, and we have the type.
Oh, is it actually though?
Yeah.
There's a double gotcha. It's actually using single quotes, so it's a character literal, but it's like that one's actually like syntactically incorrect. But it looks like I've accidentally navigated us to the answer already, which is C. It is a decimal, is the correct type. And then if you are going to use that type, you want to include that M suffix to indicate to the compiler what the type is. Oh, so that was part 2. We talked a little bit about literal values, where it makes sense to use literal values and where they might not be sufficient for the majority of programs you write. We talked about declaring and initializing variables and interacting with those variables by overriding them or using the values or data stored in a variable throughout your program's execution. And then we talked in particular about the C# syntax elements that exist for being able to infer variable types implicitly based on the context clues that the compiler can find whenever you use the var keyword, which is our key syntactic element.
Yeah.
So yeah, those were the 2 modules we went through. These are only like the tip of the iceberg for what exists in the C# language. And another thing to know, and you might know this, Samson, being an advocate, is that the C# language is always changing. We release a new version maybe like every year. The current or the upcoming version is C# 11. Each new version contains new syntax, new operations sometimes, in ways that it we think make it easier for developers to build programming languages. So this is just the tip of the iceberg. There's a lot to learn in the language, and it's always evolving to make it a little bit easier for you to write code.
One of the cool things about C Sharp, like one of the cool updates, is that you could actually use C Sharp in Jupyter Notebook for reports, and that is pretty cool.
Yeah, for sure. So if you're interested, you can check out the series of modules that we're doing as part of Learn Live and continue interacting with us. There's an upcoming session, multiple upcoming sessions, so you can keep learning more about C#.NET and all a variety of fun tech.
All right.
Cool. Yeah, I think that wraps us up and takes us to the end.
Okay, bye.
All right. Thanks, folks. Bye.